Welcome, everybody. We are beginning a brand new course here called Swift Programming 2. This course is based upon Apple's book that you can get for free. I am using the teacher's guide. There's a student version and a teacher's version of this. Both are available through iBooks. The book is called Develop in Swift Fundamentals. I'm using the Xcode 13 version, which is the newest version. And that's kind of my guide as an instructor on how we're going through the materials. For those of you that have had the explorations course, this is familiar. So it's kind of like the same kind of pattern that we did in that course. As you kind of leaf through this book, keeping in mind, this is designed for help guiding a teacher teach the course, but there's also a lot of useful information here. So it talks about like how things are laid out, little conventions they use in the book, the projects and the coding, et cetera, et cetera, et cetera. But then most importantly, here at the very beginning of the book, there is this on page 10 in the teacher guide, two links here where you can download both the teacher materials and the student materials. As I work through both the playgrounds and the projects, I am going to be working on the student materials, but I have downloaded the teacher materials just in case I get stuck or if I want to use it for reference. And you can do the same thing, but it's helpful to know where to get the stuff. For those of you that are taking this as a course here at Gateway Technical College with me, basically, here's our homepage for this semester. I'm going to be working on Unit 1 here today. So we're going to make sure everybody's got Xcode, which I know everybody does. We'll make sure everybody has the book, which I'm sure you guys all do. And then we'll get those code files, which are available here as zips as well. Or you can get them from the links in the book. And then the unit layout, and the numbering matches the playground. So when you take that zip file, and here's the student version, for example, and it's unzipped, and I have the folders expanded in this view inside of Finder. That's kind of my preferred view, at least for this stuff. And the numbering here, you can see Unit 1, and then the section numbers match up with all the playgrounds and exercises. There's sometimes stuff that's in between that's not shown here, which is just auxiliary reading material. Sometimes I cover it, sometimes I don't. But generally speaking, the way that I do this is if this is bolded, we're doing it, and then there's an assignment related to it. All right, so that's kind of the lay of the land. So where I'm going to begin here with my lecturing is I am going to take a really quick look at the book, because if you scroll on to the next page, it starts with a section that we don't have. I don't know if you guys are picking up on this. It's not listed here. So we're on Unit 1 getting started, but we go into this intro and review of Swift and playgrounds and really Xcode as well. And here they start talking about start defining your app, and really what this is kind of a way for you to think about when you're app building, what that takes, right? And it's just a little bit of a primer, and ideally you would read this, right? But you can just kind of look at it really quickly on the screen. But when we're building an app, and that's really kind of the grand goal of all this, is we're usually doing it to solve some sort of a problem, or like they call it a challenge here. And what are you going to do to solve that problem, right? And then you think about like who you're creating it for. Like if I'm creating an app for college students, it would probably look different than an app for grade school students. Or maybe if I build one for grade school students, it wouldn't work for elderly people. Those are things you think about. Now we are going to go kind of like primarily, you can see they talk here about teaching techniques. Any of you that might be a teacher that might be watching this, because that happens too, and thinking about how you might teach this. I'm working with a really small group this semester. It's just 2 students, and this is my inaugural teaching of this, although I've done the training a few times. So there's a few approaches you might want to try. So if you're teaching high schoolers, the speed at which you proceed might be different than if you're working with college students. I do find that sometimes breaking people into small groups, we did that during my training, by the way, that can be really effective. Sometimes it's better if it's teacher guided. Sometimes it's not, real frankly, it just depends on the learning style of the people involved. My approach in these videos will certainly be tutorial style. So I'm going to take what's in the books. I'm going to do it. You guys can follow along with me. And if you functionally do it, you're basically completing the work for the class and hopefully, learning something along the way. All right. So we'll kind of put that in there like that. The other thing, the reason I'm leaving this up on the screen here is once again for instructors, if you download the teacher zip file, you will notice that there's keynotes, which are like PowerPoints, basically presentations for the material. If you want to use those, that's kind of not my style or approach generally for teaching a coding class, but might be for you, right? So maybe you'll lecture and then code, whatever. But there are keynotes; those are also downloadable through the textbook if you wish, or they come in that teacher zip file. So what we're going to be doing here now is, this is what the first section is basically kind of reintroducing us to Swift and playgrounds. Like if you've maybe stepped away from it for a while. There's also kind of this thought, and I was telling the students right before I hit record on this, that if you were learning Swift and maybe you kind of knew it a little bit already, or maybe you're already coding in an Apple environment on Xcode and Objective-C pretty well, chances are you might be actually able to skip over that first explorations course and just start here. So there's a little bit of that here. So there's a little bit of kind of repeat knowledge, but it goes really, really fast, not the in-depth approach we took in the explorations course or Swift Programming 1. So some of this is kind of going to be repeat. I am now going to move the book over to my other screen. I'm using it as my guide as I record this other screen over here. And on occasion, I will pull the book back over, but I am using the teacher's version of the book. So when I call out page numbers, they're from the teacher's version of the book. All right, so you can see here on my screen, I do have my unzipped student zip file here. And all the folders kind of spread out. And I'm going to go to the very first playground, which is in section 1 here under getting started, introduction to Swift and playgrounds. And we're just going to give this a double click and it will open up the playground. And I don't know if you look at this one, you'll notice really quickly that this very first playground, by the way, is really, really basic and simple, and what we're going to start with is kind of like, hey, this is a playground. Okay, so let's do that. You'll notice when I open the playground, first of all, it's a special kind of xcode file for Swift, and the file extension on it is .playground, right? That environment, by the way, a playground, if for any of you that may have coded in Python before and may have possibly used the Jupyter notebook, a Swift playground is really similar to a Jupyter notebook in that I can write programming code inside of here, but I can also write what we call markup, which is basically words that we're putting up on a screen that aren't programming code, that describe the programming code or maybe give us instructions. And so it's kind of like a nice little mixed environment of putting info on the screen and being able to code. When we run stuff inside of a playground, and I am hitting the run button here, what will happen with Xcode is when a command is shown here, it will execute in the sidebar or in the console down below. Now I'm noticing that mine is, it's telling me the build succeeded, but I'm not seeing any output in the sidebar, which is a little concerning. So I might have to relaunch my Xcode, real frankly, and this is kind of a thing. Now, what you guys aren't knowing, if you're watching the video, is right before we started this, we were doing an app build from the previous course. And so there's a good chance that Xcode might be locked up. So here's what I'm gonna do. I am actually gonna quit Xcode, let it, and so if it had any stuff that was stuck in memory, it's all cleared out now. So I'm now going to relaunch that playground. If you are brand new to this and watching the video, the other thing that I'm going to point out, and you can see now that it's operating, right? And I don't know if you guys caught this up here, but if it's building, it indicates it here, and there's a little spinner wheel that comes up at the top of the window. But now that it's executing correctly, both in the console at the bottom and the playground sidebar, whatever programming code I've written here on the left appears on the right. Now I'm going to kind of maximize this playground, or come really close to it. I'm not actually going to do a full screen on it, but really, really close. And just, once again, for those that might be new to this environment, the way that this environment generally works, and you can see I'm trying to like move this divider here, and it's just fighting me. It's just not letting me do it. All right, whatever. All right, I'll just roll with it the way it is. Right. Normally I would move that over so you can see the whole sidebar more clearly, but we type in program code, and all this first playground is about, you guys, is kind of reintroducing you to this tool, right? For those of you coming out of that first course, at the end of that course, the last couple 2-3 weeks, all we did is app build, app build, app build. We really didn't even touch playgrounds. Then you kind of forget how they operate. What I will tell you though is whatever command you type here, the output for it will be over here. And you'll notice they have these couple different icons. So the one here allows you to see that output right here in place. The other one allows it to come up as a pop-up. So like if it's cut off, like all of these are, I can click on it and see, okay, is it actually getting over here to the sidebar, or can I make it appear here? So either one is fine. Normally, like I said, I'm usually tweaking this, and I'm not really sure why it's fighting me. And you can make this narrower or wider. So you go figure. I have no clue why it's not doing it. You also have the possibility of looking at this console here. And you notice as I'm hovering over this little arrow here, that it has the ability here, if I click on it, to actually execute the playground if it's not executing. So there are times where, real frankly, the playgrounds can get kind of hung up, especially if you're on a memory constrained machine, which a lot of people are these days. Just keep that in mind. So you have both ways to do the output. Now, all they want us to do in here, and this is an assignment, by the way, worth points. So we're going to go ahead and do this. But it says the code below prints a few short statements about what you have learned in this lesson. All right, fine. That's great. But what we're going to do now is we're going to try to do some of our own statements. So let's just do some print statements to practice. And we'll say, yeah, whatever. And yeah, you can get a little snarky with it. But just kind of get in that habit. Just remember what this does. If I was to do math in here, would it print the result of my mathematical equation? Here's the kind of thing you want if you want to test it. And the answer is yes. Notice no quotes in here. But if you look at the sidebar, it is calculating 8 in there. All right. Now, kind of as a matter of practice, and I was doing this kind of earlier with my students in a different class, also working on kind of intro level programming stuff. But they want us to put like song lyrics up on the screen if you're not really a songwriter and have your own lyrics, or you just can't remember some. You can simply go out to Google one of your favorite songs, pull in the lyrics, and drop it into some print statements. The point is on this that you might want to think maybe kind of holistically about this. So for example, I'm going to type a print statement, and I might do something like, see if I can type, "She Loves You," right, which is a song by the Beatles. And then on the second line here, I might do something like, say, by the Beatles. And then I might do another print statement. Maybe I'll make this like ASCII art or something and put in some dashes. Maybe longer than the title, et cetera, et cetera. And, you know, if you start getting clever about this, you know, you're going to have several print statements that you're going to use. You can print out a bunch of blank ones, for example, and then go back and add your words. So you can go, she loves, lowercase l, right? Loves you. Yeah, yeah, yeah. And that's more funny if you say it really, really dry. And then I'm just going to repeat that line. You guys wonder why I chose this song. It's because it repeats. And then actually the last line of the stanza is, yeah. Now you could go on and you could do a whole song. That's on you. But if you can kind of just do this stuff and just show me that you remember how you do it, this is the first playground and actually the first exercise. It is worth points. So for those of you that are going to turn this in, the way that I'd like you to turn it in ideally would be to screenshot the stuff you created. So in this case, you can use the Mac screenshot tool, and you can kind of be strategic about this. So you can kind of arrange your screen so everything fits. And then I'm on a fairly new Mac where they do call the tool screenshot. If you're on an older Mac, they call it grab. But I'm gonna kind of screenshot this, and you can see how I'm kind of like arranging it, and I'm trying to get both the code and the output screens all at the same time. And then I will just go ahead and you're not seeing this, but because it's on my other screen, but there's a little, the capture toolbar. Let's see if I can pull it over there. It's just not letting me go over there. All right, well, it's stuck on my other screen, but there's a capture toolbar that you're not seeing. And yeah, it just won't go. Go ahead, hit the capture button. And then that will save it as a screenshot to your desktop. And so all you need to do to earn your points, folks, for the class is take that screenshot and submit it here for the intro. So that was our intro assignment. Pretty darn easy, right? Just remembering what a playground is and doing some print commands. All right, so we got that out of the way. So now we're going to move on to the second playground, which is constants and variables. So I'm going to go ahead and close this playground, and I'm going to go up to the file menu and just choose close playground. Now, if you wish, you could also submit the completed playground file. That's a pretty simplistic one, so I don't think that's really necessary. All right. With this next one, we're going to go back to Finder again, and once again, expanding on that student zip file, we're now going to go to section 1.2 called constants, variables, and data types, and open up that playground. If you do get a little message on your screen saying trust and open, yeah, you want to trust and open this because it does come from the internet, so there's potential that it could have malicious code. But I don't know why Apple would do that to us, but you never know. All right. So now that we have this exercise up, let's start reading through here. And what I'll have you guys remember from the first course is that Apple, unlike a lot of other people that create programming languages, really are not teaching you how to do variables first. They're teaching us how to do constants first, which is really kind of strange, honestly. And now, if you think about why they do this, most of the coding that we do these days ends up on mobile devices. Mobile devices often have constrained memory. Like, okay, maybe you have the latest iPhone or whatever, and you got tons of RAM on it with a modern processor, but maybe you got an old iPhone like 13 or something, you know, or older, you know, and you're still using it where the memory is less. Or what we've seen with the Mac ecosystem with these new M chips that they have, the M1, M2, et cetera, is that a lot of the systems are not shipping with a lot of RAM. And sometimes, like I'm on a 16 gig unit right now, but I have a personal one that's only 8 gigs. So it becomes really important to use your memory wisely. And so one of the things that Apple prefers that we do is, instead of creating variables for everything, is to recognize that we should only use variables when we have to, and use constants most of the time, as a matter of practice when coding in Swift. And it says, okay, all right, so let's learn how to do that. It says declare a constant called friends to represent the number of friends you have on social media. Give it a value between 50 and 1,000, and then print out the value by referencing your contact. So down here in the coding area, right? So I'm gonna click down here in the playground, where I can see line numbers, because that will be code that executes. I'm going to very simply say let, and I'm just going to call it friends. Why? Because they told me to call it that up above, right? And I'm going to set that equal to a value. And this is going to be a counting number or an integer. And I don't know how many actual Facebook friends I have. I'm just going to throw a number out there. I'm going to say 250, totally a guess, right? You want to look yours up and put the real number in there, do it. Now, even though I'm not really technically outputting this information, it's getting stored. And in the sidebar, it's showing you that it's kind of reading it and reacting and knows what the value is. Down in the console here at the bottom of the screen, and you know, by the way, if you're not seeing the console, there's this little icon in the bottom corner, right? That allows it to pop up and expand, and you should be able to move it. If you remember, you know, just a little while ago, I couldn't move this divider, but on this one I can. No idea why, by the way. All right, maybe it's a problem that Apple can fix, you know, in previous or in future iterations. Now they want us to print this. So we're going to just go to the next line. We're going to issue the print command. And then inside the parentheses, we're just very simply going to call the constant name of friends. You can see in the sidebar now that it puts up to 250 inside of double quotes, meaning it's being pushed to the screen as text. And it also puts in a new line character. That's the \n. All right. So that's a kind of a skill refresh as well. And then down in the console, because we did issue a print command, it is now outputting 250 as it should. Now it says, assume you go through and remove friends that aren't active on social media. Attempt to update your friends constant to a lower number than it currently is. And it says, observe what happens and move on to the next step. So what they're telling us is, if I take friends and now I just say equals and give it a different value. So I found 10 friends that are no longer on social media, and I try to set that to 240. If you wait a second, both in the console at the bottom and through a red mark here, it says, cannot assign values to friends, let constant, right? So in other words, friends is a constant. Let implies that friends is a value that cannot change. It's stored in memory with this name, but that value cannot change, right? And it asks, does it compile? Why not? Well, okay, well, the why not is, and we know the answer to this already, but just in case you forgot, because a constant implies the value is set and it cannot change. Now, this also tells you a little bit about how memory is managed on a computer, because if I put in a value that holds a certain amount of memory space and it can't change, I only have to give it enough space in memory to hold that value, right? And then I can free up the rest of the memory to be used more efficiently by a different variable or constant or function or whatever, right? Helps my operating system operate more smoothly. And if I was instead to basically apply a variable occupies more space in memory because it doesn't know how much space it may need. So it will over allocate space to itself, making your application less efficient. So this really tells you a little bit about how Apple is operating, you know, to make their apps work quickly and efficiently on limited RAM. All right, so they're saying to go back and delete this line of code that tries to do the update, but I'm not going to do that. I'm actually going to comment it out. So I'm just going to put in 2 forward slashes so we can see that it's there and we tried it. Notice the error message go away. And then it says, go back and update the line of code so that friends is a lower number. And the only way that we can do that if we're using a constant is to find the original declaration and then change it. Okay, so that's the only way to do it. All right, hopefully you got that to work. All right, so the next one is actually one of our exercises. So this is whenever we hit like in one of these playgrounds and it says app exercise, this is a thing you turn in, by the way. The previous screen, that was just practice. This is the real deal, right? So let's go ahead and figure this one out. So it says, and notice these exercises reinforce Swift concepts in the context of a fitness tracking app. So that's kind of what we're working off of, is fitness tracking. So it says your fitness tracking app needs to know goal number of steps per day. And so it says create a constant called goal steps and set it to 10,000. Right, so I'm going to come down here and I'm going to click and I'm going to say goal steps, and I'm using what we call camel casing, the second logical word in that constant declaration. Starts with a capital letter. I am forgetting the keyword of let, so here I am dropping the ball right off the bat, just like the Detroit Lions. Bad joke. That'll only be funny in the winter of spring, or in the winter of 2024. Every other joke, what are you talking about? Nobody remembers the losers, right? But we could put the Packers in that mix too. All right.
Yeah.
So, all right. So we're gonna let goal steps equal 10,000. Let me just type that in. All right. So there it is defined. Now we're going to use two print functions to print two separate lines to the console. The first should say your step goal for the day is, and the second line should print the value of goal steps by referencing the constant. So once again, this is repeat from the first screen. So we're just going to do text and we're going to say your step goal for the day is the colon. On a separate line, another print statement. We're just going to put in the constant that we just created, close the parentheses, and there you can see the output in the console and in the sidebar. And if this worked, your first app exercise is complete. Screen capture it and save it, and let's move on. You guys
I am currently dealing with Xcode crashing on me, so.
all right. Well, I'm pretty certain that you can catch up with us, Jonathan. So I'm not too worried about that. Compared to the stuff we were just doing, this is like much simpler, and it's kind of like almost like a relief after working on that. Right. All right. So that's how we complete that first app exercise. Put text on the screen, set a constant, display that constant on the screen in the console. All right. Moving on. All right. Next, we have an exercise that says declare a variable schooling and set it to the number of years of school that you have completed. All right. So let's, and then it says print schooling to the console. So let's do both of those things. So I'm going to create a variable. Now with a variable, we use the var keyword, VAR. We are going to use the name that they're suggesting, which is schooling. And I'm not sure I want to type this number in. How many years of school have I completed? Plenty. Right. Well, I went through K through 12, right? So we won't count the K's, but we'll count the 12, right? I did 4 years of college, 2 years of college, another 2 years of college, another 2 years of college. I don't know what that adds up to, but that's a whole bunch. Let's just call it, let's call it 20. Sounds about right for me, you know. Too much school for me. Right. Maybe someday you'll reach that number too. Who knows? If you would have asked me when I was in high school if I'd ever reach that many years of schooling, I thought it was highly unlikely because I was an overachieving C student. I was that very good in high school because I barely showed up. We do want to print this out, so we're just going to call the variable in. And you'll notice that just like a constant, you can print out a variable. That's kind of the point. But here's the difference. Because schooling is set up as a variable, now I can reassign its value. So I just did another year of school. I can add that here, make it 21, and then I can re-output it. So I can just paste that back in, and then it will update to 21. All right. Now, yeah, and what they want you to do here is print your explanation to the console as to why this compiles or not. I'm not going to do that, but we can just very simply say that a var allows us to change our value. A let does not. If you know your value is not going to change, you use a let. And for people who are experienced programmers, this is a little bit uncomfortable in an Apple environment. It was for me, at least, that they lead with constants, because in just about every other language, we do it the other way around, right? And if you're a Python programmer on top of it, you figure out, hey, there are no constants in Python. Everything's variable, so it's constant in name or symbolism only, not in actuality. But this is an important concept that has a lot to do with memory management. Once again, if you're wondering the why we're talking about this, it's all about that memory management. All right, once again, we're on the screen here. We're on the app exercise. So this is one for points. This is basically just as easy as what we just did. All right, so we're going to go back to the step tracker, fitness tracking app thing. We're going to create a variable called steps. So here I am doing it. And right now we just woke up, didn't put on our smartwatch yet or whatever, put the phone in our pocket. So we're setting our steps to 0. And then, you know what, we're going to print that to the console. So this is kind of the continuing pattern here. So we're going to print steps, and you can verify for sure. Yeah, it's 0. No problem. Now, assume that your fitness tracker has been running all day, and you walked a whole bunch, and I do have this thing that I do with my friends every Sunday, or try at least. We go out for a walk, and we try to do a few miles, by the way. On a really good day, we do like 5 miles. On not so good day, we do like 2-3 miles, something like that. But let's say I did a whole bunch of steps. Now my steps are up to 5,432. Just put in a number, and then let's make sure that actually stored. So we're just going to print that out again. And once again, practicing print steps. I do want you to notice, interestingly, kind of like the difference between the sidebar output and the console output. Notice in the sidebar, like when we did steps here, it even formatted it with a comma. It's sure not doing it here. There is a way to do it, by the way, where you can force it to format like that. That's not really the concern here, but that's the solution here. And okay, well, we were supposed to set this to 2000. I fudged that number. We printed it. We did that. And then you're supposed to print, and you may as well just do this. You may as well practice and just say, good job, exclamation. You're well on your way to your daily goal. All right, so there you go. All right, all of this so far is brute force, but now we see really clearly the difference between a variable and a constant. Had a little more practice on it. So we are moving on. All right. All right, so now we're going to set up a little scenario here. It says, imagine you're creating a simple photo sharing app. You want to keep track of the following metrics for each post: the number of likes a photo has received, the number of comments, the year it was created, the month it was created, and the day it was created. And it gives you like specifics on each one of those. And so now they're having you think about this, like for each of the metrics above, declare either a constant or a variable and assign it a value to a hypothetical post. And it says be sure to use proper naming conventions. So we'll practice all of that. But more importantly, what this is really having you think about is, should something be a constant or a variable, and knowing when to select it, right? All right, so let's just kind of begin that process. So let's think of all the names that we're going to use here. So we have the number of likes. Okay. Variable or constant?
That's gonna be a variable.
Right. Because we hope we get more, right? More than 0 likes. So let's do var, and notice the naming here, num of likes with camel case. Try to be verbose in how you name things. I mean, I could just call it likes, right? This is a little bit more descriptive. We'll preset that to 0. Okay. What about number of comments?
That's
Variable
also
or
gonna be a
constant?
variable.
Yeah, agreed. So num of comments. We'll also preset that to 0. Year created, constant or variable?
That's gonna be a constant.
Yeah, right. So now you're starting to see it. So year created, and you know what, since it's going to be a constant, well, let's just put in 2024, right? Assuming the picture was taken now. The month created, I think it's pretty logical to think same situation.
Yeah.
And well, we can handle this. Well, it says there the month post was created represented by a number between 1 and 12. All right, so we'll just put in, it's January, we'll put in 1. And the day created, I see this as a constant also. So, and we'll say day. And that would probably be a number between 0 and 31, right? Depending on the month. What is today? Today is the 30th. Just put in today's date.
Mhm.
All right. Now, didn't have us do anything to output anything, but what was the exercise here? To think about, should it be constant or should it be variable? Right. The moment you snap a photograph, right, it's taken, right? When it was taken, that doesn't really change. You know, in a practical sense, on the software level, you can actually change the metadata on a photograph, but that's not what we're doing here. All right, let's move on to the next piece. Right. Once again, we're hitting the fitness tracking thing, and following the same procedure here, we're going to go ahead and like fill in all of this information. So, and it says there's all sorts of things that a fitness tracking app needs to keep track of in order to display the right information to the user. Similar to the last exercise, declare either a constant or a variable for each, assign each a sensible value, and be sure to use proper naming conventions. All right. So let's begin by doing that. All right. So let's start with name. All right. Now let's have this discussion. Constant or variable?
That would be a constant.
Okay. That's the inclination, Jonathan, right?
Uh-huh.
I'll say
And
it's a
we say
variable.
that from a male perspective because we usually don't change our name as we grow older, right? But
Oh,
women change their name when they are foolish enough to marry us, right? And take our name. Some of them don't. But also it's not impossible that you might decide to legally change your name at some point. So I'm going to argue variable here, right? All right. Maybe this isn't right, but whatever. And I'm going to call it name, variable name. And you know what? I'll just put in my real stuff here. So there we go. Takis. What about age? Variable or constant?
Variable.
Yeah, that is going to change. Now, if they said date of birth,
That's a constant.
Yeah, that would totally be a constant. So age here, I guess I'm only 29, so let's go with that. Let's add 30 years to make it real. All right, that's the real data. All right, number of steps taken today. I'm not wearing my watch at the moment, but variable or constant.
Variable.
Yeah. So number of steps today. That's what I'm going to call mine. You can call it yours wherever, but I'm going to encourage you, be verbose, be descriptive, right? And I'm just going to pop a number here. I know I haven't had many steps, but I'm, just landing my fingers on the keyboard. 2, 3, 4, 5. Right. I'll just say that's my thing. What's my goal for the number of steps? Should this be a constant or a variable? Well, I could argue that it would vary, but I think that once you set it in your app, it becomes a constant. So I'm going to make this one a constant. I'm going to say let goal steps equal, and we can use the number they had before, and that's actually a pretty good goal for steps. I do have a smartwatch, and I do keep track of my steps from time to time, and they say that an active person usually walks about 5,000 steps a day, like as a considered a level of activity. On a really busy day, if you clear 10,000, but I've had days where I've hit like over 20,000. Like, if I go to like Summerfest or something and you're walking around all day and that kind of stuff. But that's a pretty good goal. What about average heart rate? Variable or constant?
Variable.
Yeah, totally. And I'm just going to call this AVG heart rate, right? And then, gosh, I really don't know what to put here, but I'm just going to type in a number I think is kind of normal, which is like 72 beats a minute. I think it's pretty normal, right, for a heart rate resting. But that could change, right? And that would be calculated. If you do have a smart watch, by the way, it can even calculate your blood pressure and stuff, which is pretty freaky. But it can do that just by touching your skin. Pretty weird. Now it says, now I'll go back and add a line after each constant or variable declaration. On those lines, print a statement explaining why you chose to declare the piece of information as variable or constant. All right, I'm going to do that, but I'm going to do it really quickly. Say print, say, hey, choose to change my name so a bar, something like that. If it's helpful for you to speed up your process, do copy paste. Please feel free. That's what I'm doing. I'm going to say I may choose to get older. Unfortunately, I will get older. Number of steps today. And why is that a var? Eventually, eat a snack or to go to the bathroom. Right. That's why so I'm gonna have to get up at this one. Right. Now, I think a lot of people would make their name a constant, real frankly. The age thing, once again, if you had your date of birth, that would be a constant. And clearly, your heart rate. That will change. So that was kind of the goal of the assignment. If you're screenshotting to turn it in, I would probably capture this. Right. So that this is an assignment here. So make sure you get that one complete. All right. I am going to move on. I assume you guys are okay with this material. Once again, this is all refresh and repeat.
Yeah, I'm good.
Yeah, okay.
Now we're looking at types and type safety. And it's asking us to begin by declaring two variables, one called first decimal and one called second decimal. Both should have decimal values. Look at both of their types by holding the option button and clicking the variable name. All right, so let's do this. So it did say variables, right? So these are going to be vars, and one's called first decimal. We'll make that equal to, I don't know, 1.2. And another var, we'll call it second decimal. And we'll set that one to 2.3. Now we see what we typed in, so we know they're decimal numbers, right? However, and we're kind of leading towards this thing here. And what they're trying to show you is if you hold on your option key and hover over something, notice how it has a question mark that pops up, and I'm kind of moving on and off so you can see it. If you go ahead and click that, it will look at the variable type, and notice it will recognize that it's a type double, which means a floating point number. So I didn't have to tell it that it's a double. It knows that it's a double. Now, going back to the first course again, whenever we start learning about how to store values and stuff, we learn about strings, right? We've learned about numbers. We've already kind of used them. But so far, we've been using counting numbers. Here, we're using floating point numbers. Now, interestingly, if I was to come in here and change this to a 2, right, and let it recompile, hold down the option key and click the question mark, notice how now it's thinking it's an integer, right? And you notice it's happening automatically. If I change that number 2 to 2.0, still 2, right? But if I hover, option click, now it's seeing it as a double just because I added the 0.0, even though technically it's a whole number 2, right? But what's happening here is Swift is automatically determining the data type and working with it. All right. All right. So now they're asking us to kind of ramp this up a little bit. It says, declare a variable called true or false and give it a Boolean value. All right. So let's do that. So variable, we're calling it true or false with camel casing, and give it a Boolean value. So let's just say true. Try to assign it to first decimal like so. First decimal equals true or false. Now let me type it in, right? You can see in the console down below, it didn't like it. Now the red pops up and it says cannot assign value of type Boolean to type double. And so once again, if I option click over this, it tells me it's Boolean right here by virtue of the fact that I gave it a Boolean value. So this is not going to work. And it's asking, does it compile? Of course it doesn't. And then, it says print a statement to the console explaining why or why not. And so if you want to do that, you could do something like this. You could say, you cannot assign a Boolean value to a variable of type double. It's not going to work. All right, with the next thing it says, declare a variable and give it a string value. All right, let's just create one. Here's a variable. I'm going to call it some string. Right, and I'm just going to put in my famous whatever. Right, then try to assign it to first decimal. So I'm going to once again say first decimal equals some string. Of course, you can already anticipate this is going to fail. I'm just giving the compiler a second to catch up. So now it's saying you can't convert value of type string to double, right? And then of course it wants an explanation again. So if you want to really follow through with that example, you can say you can't put a string in a double. That's probably enough. All right, so it's failing. If you want to get rid of the failure, 2 forward slashes at the beginning. All right. They're going to have us do this again. So variable with some whole number value. So we'll just call it, whole number. Let's put in 10. Then try to assign that to first decimal. So I'm going to put in whole and type it, whole number. That's also going to fail. I think we've already figured this out now, right? So let's give it a second to fail. And then, of course, let's comment it out. So it doesn't. And, you guys should type in a thing here, but I'm just going to say, I'm going to be a little snarky and just say this. Print the above. And basically, data types must match. And that's a real key thing. Now, if you want to really kind of think about this in kind of an interesting way. Now, in this case, we're trying Booleans, we're trying decimal values, other values. What if, okay, here I'm trying to apply a whole number to a decimal number and it's not letting it do it, right? Why wouldn't it just allow it to work? Right? It's like whole number is 10. Why doesn't it just automatically become 10.0 and go in there? And this is a really important tidbit, right? So this indicates to you that Swift, even though it appears to be simplistic like Python, is actually what we call a strongly typed language, meaning that a certain data type is all that can go into a variable structure because the variable structure is built to hold it, right? So for example, if I have a bird cage, meant for a parakeet, I'm not going to put my 200-pound dog in the bird cage. It's not the right kind of container for it. I could try, but it probably won't work. Even if the dog was small enough, it probably wouldn't work in that cage. You know what I mean? So that's the same thing also with data types. All right, I'm going to move on to the app exercise here. And so we're going to work on this one here together. And it says, you have declared a number of constants and variables to keep track of fitness information. Declare one more variable with a Boolean value called has met step goal. All right, so let's do that right here. I'm just going to declare it. We're going to call it has met step goal. And this is supposed to be Boolean, right? And we're going to say true or false here.
So false.
Yeah, let's go false because we don't know that yet, right? So let's set it to false. when you declared a constant for goal number of steps and a variable for current step count, you assign each value in the thousands, and this can be difficult to read. Redeclare this constant and variable, and when assigning each a value in thousands, format the number so it is more readable. Okay, so let's go. I don't want to retype this stuff, so I'm clicking back a couple of pages here. And I can come in here and grab this stuff and just kind of delete. And actually here, let's grab these two values. I know I'm grabbing a print statement too, but I'll get rid of that. So I'll go forward 2 screens here, and I'm just going to paste these in. I'm going to get rid of the print statement because we just don't need it. And there I have my number of steps today and my goal steps. Now, we want to format this. In other words, we want our numbers to look like the numbers over here on the sidebar. Now, all right. Now, if you guys are like us, so everybody here in the session, I had paused the recording, by the way. We all forgot how to do this, right? So it shows how well it sticks. So don't feel bad if you don't remember from the first course or if you're new to this. But basically what they do is they put in an underscore here in the spots where you want the thousands to display. Now, in the sidebar on the right, this automatically puts in the comma anyhow, so you're not really seeing it. So the only way to know for sure is to do a print and print each item. So let's do goal steps. Okay, I don't see a comma there. How about you guys? And so I don't know if this is really relevant. And I think what I'm coming up with, and this is kind of resonating in my brain after the fact, it makes no change on the output, right? That's handled with a different formatting mechanism. But the point here is if you're looking at a super uber long number, you can put in the underscores. They have no effect on the number, but it makes it easier for you to read. That's certainly easier to see that this is 10,000 than it was before, right? Where you might say 1,000 or 100,000 by mistake. All right, so that's kind of that. That's kind of weird. All right, I'm not really sure the usefulness of that. They must have developed it for a reason, probably for number crunching. So, all right, so that was that exercise, by the way. Let's work on this one, and we're getting near the end of this playground here. And once we finish this playground, we'll take another break. All right, so this one's about type inference and required values. It says declare a variable called name of type string, but do not give it a value. Let's start that. So variable, not declaring the type here. We're just gonna call it name. And how can I enforce that this is a string? Well, I can put empty quotes here, right? And then when I print name, it will do it. And it is blank. And it is working down here, even though it doesn't seem like it's doing it. So that's kind of the general approach on this. Now, this is kind of goofy, but I'm going to actually, I have the teacher's version of the playground open here, and I'm going to move forward in the example, but this is what I was suspecting that we're missing. And this is the teaching point here. So the one way to do this is to do what I did. And by putting something on the right side of the equal sign, indeed, if I use the option click on this variable name, it tells me it's a string, right? But I'm sending it an empty value. The other way to do this, so I'm going to comment this out and leave it. In fact, I'll say the old way. Old in the old way, like that. Or maybe the better way is I declare a var I give it a name, a colon, and then I indicate its data type like this. Notice I'm not giving it a value. And then I try to print to it, and it says, does it compile? Now, I'm trying to print something, it doesn't have a value.
Mhm.
So I can't, right? So the answer to does it compile is no, right? So I'm going to put forward slashes here. Now, if I give it a value, so now I can just say name equals, you know, whatever. Doesn't really matter what the word is. Now, if I do the print, does it work? And the answer, of course, is yes, because I put something in there. All right, let's practice that again. Declare a variable called distance traveled and set it to 0. Var distance traveled. We're setting it to 0. Okay, seems pretty straight ahead. Do not give it an explicit type. So it does not want us to say double or Boolean or any of that kind of stuff, right? And all right, so we did that. And it says now try to assign a value in distance traveled of a decimal number of 54.3. And what happens? It will fail because here it cast to an integer. Once again, option click tells us it became an integer automatically. And here we're trying to put a floating point number in it. Now, of course, if we wanted to adjust this, right, we could up here do one of two things. I could go 0.0, for example, and now it'll work. It'll take a second for the error to clear. Because now, if I option click, we can see that it's a double. Or I could do this as well. And then can I assign it a plain 0 if I call it a double? Well, apparently, yes, because it's working and not crashing. So if I put a whole number in, but have declared a variable type as a double, which can hold a floating point number, I can put 0 in. It must be automatically converting that 0 to 0.0 and putting it on the screen. But it is working just fine. Yeah. And so this is called setting an explicit type. And generally speaking in programming, and I'm just saying this from experience, right? Whenever you're using a strongly typed language, it's usually better practice to declare the data type. Some languages don't let you move ahead unless you do. Like if you're coding in Java, if it's an integer, you got to tell it it's an integer. It's a double, you got to tell it it's a double. Swift has a little bit of that like Python / JavaScript thing in it where it allows you to dynamically adjust without declaring it, but it casts automatically to the right data type. My concern always with programming is, hey, you're allowing it to cast, and what if you screw up your code and it can like really break your program? So it's usually better to be explicit with the data type if you can do that. All right, we're moving on to the last screen here. So this is the exercise piece once again. And so let's work on this together. And it says you decide that your fitness tracking app should show the user what percentage of his/her goal has been achieved so far today. Declare a variable called %complete, set it to 0. Do not explicitly assign it a type. So let's do that. Var %complete equals 0. Now it says, imagine that partway through the day, a user has taken 3,467 steps out of the 10,000 step goal total, meaning they're at 34.67% of the way to the goal. Assign 34.67% completed. All right, we already kind of know what's going to happen here, right? Percent complete equals 34.67. This will, of course, fail because it thinks it's an integer, right? And the answer to compile, no. And then if we come up here and explicitly declare this as type double, spelled correctly, of course, then the compile error goes away. And that's the exercise. All right, folks, we are gonna pause the video here and we are gonna take a break. All right, so we did finish this playground, so we are gonna move on to the next. I'm gonna go ahead and close this playground right up here. And I also had the teacher version open, so I should close that one too. And then I'm gonna go back to my student zip here. And we're going to move on to the next playground, which is the operators playground. So go ahead and open that. Do a trust and open if it asks. And we're going to do some math stuff now. And, basically, as you can tell from the name of the playground, the point is to kind of review all the mathematical operations and how they work. So some of this is, I'll call it really fundamental, but there's also a couple little wrinkles in here that maybe we haven't thought about a lot or haven't thought about for a while, at least, just to kind of refresh your memory as to how things work when we're writing Swift code. Okay, so I'm going to begin by, first I'm going to make the window just a little bit bigger, make the console appear so we can see it. And let's just read the instructions here. And it says, you decided to build a shed and want to know beforehand the area of your yard that it will take up. So we want to create two constants, width and height, with values of 10 and 20 respectively. So let's do that. We're going to say let width equal 10, let height equal 20. We also want to create an area constant that is a result of multiplying the two previous contents together and print out the result. So we're going to say let area equal width times height. Right. And then it's saying output, so we're going to do print, and we're just going to print the area. You can do it with string interpolation or whatever you want to do, but for right now, let's just get it on the street. If you want to get persnickety, you could, if you wanted to use string interpolation, you could say the area is space, and then if you remember string interpolation, we haven't talked about this for a bit, but basically backslash the name of the constant or variable inserted inside of parentheses like this. So that's with string interpolation. All right, so the next instruction says, you decide that you'll divide your shed into two rooms. You want to know if dividing it equally will leave enough room for some of your larger storage items. So create a room area constant that is the result of dividing the area in half and then print out the result. So here's a let, we'll call it room area. And that's going to be the result of taking the area and dividing by 2, right? That's half. Or you can multiply by 0.5, same difference, right? And then once again, we could borrow this print statement here. So let's do the output, and we'll say the room area, or actually, maybe more accurately, half of the room area is room area. So that should be half of it, or 100. Then they're saying create a perimeter constant. So we're going to say let perimeter equal, and its value is equal to the width plus height plus height. Or, okay, so let's do it the way they're suggesting. So I could say width plus height plus height. So kind of reintroducing you to the whole concept of like, remember how to do addition, basically. So we're going to print perimeter. You want to do that with string interpolation. You could say the perimeter of the area is, and then we do backslash parens perimeter, and then you don't need this out here. So that's with string interpolation. So let's try this next one. This next one says print what you expect the result of integer division of 10 divided into 3 to be. Create a constant that is the result of it. So I want you to read that really carefully. We're not going to do integer division. We're going to speculate as to what the answer is and create a constant relative to that, if that makes sense, right? So we're not going to actually do the math. But if I divide 3 into 10, it doesn't go in there evenly, right?
No,
How many times does it go in?
only twice.
Yeah, 3 times completely. So when we do integer division, we're only getting the whole number answer without the remainder. So here's our constant. Let integer division result equal, we anticipate 3, right? And we could print that. So we can say print. All right, I'm not going to do the whole string output, but there it is. All right. Now it says create 2 constants, double 10 and double 3, set to 10 and 3, declare their types as doubles. So let's do that. Let's go. Let double 10 double, right, to make it a double. We're going to set its value to 10. Then we're going to let double 3 also be a double and set its value to 3. Noticing I'm not using a decimal point here. Right. Then also declare another constant called division result, which is equal to the result of double 10 divided by double 3, and then print the value of that. So if I just print division result, you will notice that it will output the decimal places. Notice how many, it's a lot of decimal places that it goes out to. It does at some point stop. The reality is, like, if you were to look at this mathematically, the remainder never stops, right? Because when you look at a 1/3 value, it's 0.3 repeating forever, right? But this shows us that by just changing the data type, it changes, you know, how that goes. Now, if you want to experiment with this, right? So if I were to remove these declarations that make them a double, and now we let it run, notice how because these are integers and it's trying to divide 3 into 10, even though the result is really still technically 3.33 repeating, it can't display that because we're working with integers and we're doing integer division here, which doesn't show us the 0.3. So it gets rid of that. Now why this is important is because you can leverage this feature to your advantage, right? Like sometimes you want a decimal point, sometimes you don't. Depends on like what the precision is. So I'm going to actually control Z this, but that's kind of the example of integer division happens automatically when you're dividing integers. And if you're expecting a decimal answer and you're dividing two integers, it won't resolve to a decimal answer unless you force at least one of them to a double, by the way. All right. All right, so now they're giving us an example for pi, and it says, given the value pi, so they already have it set there, create a radius constant with a value of 5.0. So we're going to say, let radius equal 5.0. Not declaring a type here, just doing it. Then it says, calculate the diameter and circumference of the circle using the following equations and print the results. So they're giving us the equations, thank you. Because like who would remember these, right? But I could say, let diameter equal 2 times the radius, right? The asterisk is used for multiplication, since we're kind of reviewing that. And then we'll do let circumference equal 2 times pi times the radius. And then here at the bottom, you want us to print the result. So we could say print, you can do this in two separate statements, however you want to do it. You could say the or how about the diameter is \diameter. And then we do another print, say the circumference is, and then we do \circumference, and there you go. And you can see your output in the console below. Just practice. So we're doing multiplication, we're casting the different data types. Notice the preference here to go to constants, right? To just kind of reinforce that whole thing. You know, we're using constants almost exclusively unless we know something's going to change. And in this case, we have no need to change it, so I do it. That's just to move on here and then create an integer constant. And then using the modulus operator, set its value to the remainder of 12 divided by 5. Okay, so we're going to do a let, and we're going to call this some, I'm going to call it like sum int. Okay, so I'm going to call this an integer constant. And it wants us to be an integer, right? So I'm going to actually declare type int here, right? Now I don't know if you guys caught this as I was typing that, but notice how there's int 32, 64, 8, and 16. Now it's starting to look a little bit like Java, because when we work in Java, for example, we can use different sized integer containers depending on how much data we expect to feed into it. The plain int holds the largest type of value, but the other ones scale down depending on how much memory space you're taking up. So that's actually possible in Swift, something we haven't really talked about though. All right, but then we're going to set this value to the remainder of 12 divided by 5 using the modulus operator. So the modulus operator, if you do not remember, is the percent sign, true in most programming languages. So it's going to divide 12 by 5, but it's not going to give me the whole number answer. It's going to give me what is left over. 5 goes into 12 twice for a total of 10 with 2 left over. That's why there's 2 in the sidebar, right? So there it is. Didn't ask us to print it out, so I'm not doing it. Right, you can print it if you want, whatever. Now we want two more integer constants, even and odd, and set them to any even integer and any odd integer respectively. So let's do that. So we're going to say let even colon int equal 6. Let odd colon int equal 7. All right. For each, print the remainder of dividing the value by 2. Okay, well, it's not telling us how, right? So should I create a variable or a constant, or should I just do a print statement and do the math inside the print? It doesn't really specify, right? So here's what I would do. So I'm going to say let answer 1. I'm not going to put a type on it. I'm just going to let answer 1 equal even divide the remainder. Okay, so then we want the modulus operator, right? So we're going to say even divide by 2. I can see in the sidebar what the value is. So if I send 2 into an even number, is the remainder actually 0? Yeah, that is, right? That's how we know a number is even. And then I could say let answer 2 equal odd mod 2. And we know that's going to give us 1 as a remainder, because that's how we know it's an odd number. Yeah. And that's what they're really asking us, like, can you use the remainder operator to determine if an integer is even or odd? Absolutely. Really common programming technique. Sometimes that's a very relevant piece of information. I'm assuming you guys are all good?
Yep.
Fantastic. I'm going to move on. Let's go on to the next thing. So that was the first page. All right. You see how these get a little longer as we go forward. All right. So we're going back to this fitness tracker app thing, right? And it says your fitness tracker keeps track of users' heart rate, but you might also want to display their average heart rate over the last hour. Can create 3 constants: heart rate 1, heart rate 2, and heart rate 3. Give each constant a different value between 60 and 100. Let's do just that part first. All right, so let's say let heart rate 1 equal all right, let's go 65. Let heart rate 2 equal 77, and then let heart rate 3 equal 89. Let's go 88. Next, it says create a constant added HR equal to the sum of the 3 heart rates. So we're going to say let added HR for heart rate equal heart rate 1 plus heart rate 2 plus heart rate 3. So that's stored. Then we want to create another constant called average HR, heart rate. That's going to take the added, and see, I called it add here, so I'm going to change it to added like I'm asked. So I'm going to take the added HR and divide it by 3, which will give me the average. And then they want us to print the result. And you can get fancy with this, but I'm just going to open the average. And it says my average heart rate 76 with those 3 numbers. All right. Now it says create 3 more constants, and this is heart rate 1D, 2D, and 3D, equal to the same values as the ones before, right? Okay. However, these should be of type double. So let's kind of do the process here. So let heart rate 1D double, right? So we're setting it to be a double equal to 65. Do I need to do 65.0?
No,
I don't. Let heart rate 2D double equal 77. Let heart rate 3D double equal. Now they want us to basically replicate what we did here. So here's my clever hack, by the way, because our code is so similar. I'm just copy pasting here. We're going to add a D to each one of these variable names or constant names, technically, right? Oh, wait, I did that wrong, right? Okay, sorry. And here I thought I was being clever. And then we're going to have a new average HRD for double. And we're just updating these. And then kind of the point is, are we still ending up with the same answer? And you know what? We are not. Okay. Now I happen to pick numbers that worked out to a decimal number. That was accidental, right? But you can see that there is more precision this way when you're using double. So if the 0.6 is relevant, yeah, you include it. Now I'm going to say for a heart rate 76 versus the 76 that we got above, which one's more accurate? And I want you to think about this. If I was looking at the number 76.6 and I asked you to round it to the nearest whole number, your answer would be 77, not 76. So what it's showing you is that integer division has an imprecision to it, right? And that's got to be accounted for. Really, down here, I mean, this should have been really a double to get an accurate answer, right? But I think it's pretty fascinating though, right? Now it says, imagine that partway through the day, a user has taken 3,467 steps out of the 10,000 step goal. Create constants, step and goal. Both will need to be of type double so you can perform accurate calculations. So let's do that. Let steps of type double be equal to 3,467. Let goal also of type double equal 10,000. Right. Create another constant called percent of goal. Right. And I want you to like read the instruction here. It says create a constant percent of goal that equals an expression that evaluates to the percent of the goal that has been achieved so far. Okay, they're saying do the math. They don't say declare the type. Now, as an experienced programmer, I would probably set this as a double right now, but I don't have to because the other numbers will cast it. And so if we want to get the percent here, we're going to take the steps and divide it by the goal. And then you'll see in the sidebar there, it evaluates to 0.347. And then, you know, if you want, of course, you can always print it. Say percent of goal, and then see it in the output there. And then really, right, if you want to change it so it's an actual, like reads as a percentage, you would, it would be 34.67%. So you could output it so it looks nice if you wish, but that's on you. Right. But there's the example on that one. Assuming you guys are good, I'm moving ahead.
Yeah.
All right. And hopefully all of this stuff is bringing back what you learned or reinforcing it. But we're setting a baseline here, folks, for kind of remembering, and then a baseline for moving forward with new things that maybe we really didn't do so much of the first time around. All right, so this one's going to be a compound assignment statement, which you'll see what I mean when we say it. We're going to declare a variable whose value begins at 10. And then using addition, update the value to 15 using the compound assignment operator. All right, so let's just do that first. So I'm just going to come over here and I'm going to declare a variable, and a variable. And let's just call it num1. That's a good number. We'll set it to 10. Okay, integer or double? Well, integer automatically, right? Then it's saying to do a compound assignment. And what they mean by that is when you do the plus equals statement, right? Which is the same as doing num1 plus a number, right? Or you can just say plus equals 1. So it takes the number it is currently, adds it to it, and stores it back inside. And so I can get this up to 15 by simply copy pasting this a few times, and you can watch the sidebar there as the value increases. This is 14, right? And there's 15. I could have done it all in one step too. I could have like just plus equals 5 and be done with it. But this is a really common technique for incrementing things. That's why I did it the long way. Now it says using multiplication, update the value to 30 using a compound statement. Right now it's at 15, right? So I'm going to put a little note here. Current value at this point is 15. Failing on all keystrokes here. All right, so now if I want to use the compound operator to get it up to 30, I'm going to take 15 and multiply it by what?
15. No.
2, right? 2 times 15 is 30. So now I'm going to say num1, instead of plus equals, we're going to go multiply equal 2. So it takes whatever's in num1, multiplies it by 2, and puts it back in num1. So now we're up to 30. Right. Now, if you want, and it's asking here, by the way, that we should really do this, you know, and here I am, like, I can't even do the print statement, right? And we're just going to output num1. You know what? I'm not going to do this like overachieve here, but what they're really asking us to do is, you know, this. You know, and we're already kind of getting the output in the playground sidebar, right? But it does help us to confirm, right, that we're doing it right. And then one more time after this compound multiplication. Now, most of the time when we do like plus equals or minus equals, that's usually what we use is plus or minus, you know, and we're usually incrementing a value. But we forget that if we can conceptualize it, and it becomes more difficult when we use multiplication or division or modulus, but all of those work with the compound statement too. So you can go plus equals, minus equals, asterisk equals, or forward slash equals. All of those work, and percent equals too. If you can even wrap your mind around that, you can do that too. All right. I personally have a hard time with that one. You know, but not so bad when the numbers are simple. When they get complex, yeah, it kind of blows your mind a little bit. All right. Now they want us to create a variable called piggy bank. So let's call that piggy bank that begins at 0. All right. You're going to use this to keep track of the money you earn and spend. So for each point below, use the right compound assignment operator to update the balance in your piggy bank. All right. Now, we didn't mention this here, but it looks like all the values are integers, so leave it as an integer. But normally, I'm going to just say this from a programming standpoint. Normally, when I think of money in a program, I always think double because it includes the dollars and cents, and sometimes that's very relevant. In this case, I'm going to say not, so let's not worry about it too much because that's not really the point here. All right, so first, our neighbor gives us $10 for mowing her lawn. So we're going to go piggy bank plus equals 10, right? So we added $10 to the piggy bank. Then we earn 20 more dollars plus equals 20, doing odd jobs. Then you spend half of your money on dinner and a movie. Okay, so now I got piggy bank. What do I put here? The plus ones are easy. What do I put here?
Wouldn't it be
I
minus?
spent louder.
Wouldn't it be minus equal?
So how are you going to get the half?
Oh wait, my bad.
Divide equal.
Yeah, divide.
Okay, divide equal is correct, but now what number are we putting in here?
Be 2.
Right, we're dividing it in half, so we're dividing it in 2. That gives us half. And you can see in the sidebar, we went from 30 to 15, so that's correct. Triple what's left in your piggy bank by washing windows. So now we're going to say piggy bank, we're going to triple it, right? So now we're going to multiply equals by 3. And now the money will go from 15 to 45, which is tripling that. And then we spend $3 at the convenience store. So that's a minus equals 3. But we did get through at least all the major operators, right? All right. And although I'm pretty certain modulus works here too, I tend to avoid it. Plus and minus, you will see often, forward slash and asterisk, maybe not quite as much, but it does work, right? It's all in the conception, right? If it does not resonate with you to do this compound operator, just keep in mind that you can always lay it out the long way if that's easier for you. No harm done. All right. We are now moving on to another exercise component here. So this is a turn-inable thing. Let's read the instruction here. It says the most basic feature of your fitness tracking app is counting steps. Create a variable steps and set it equal to 0. So let's do that first. Variable steps equals 0. Then increment its value by 1 to simulate a user taking a step. So I'm going to say steps plus equals 1. All right. So there it is. So we're taking a step and then it's adding. Now you can imagine this. I mean, I'm not sure how they worked out the technology on this in your smartphone and your smartwatch or whatever. It must like feel your motion and the abruptness of it stopping in order to count the step, you know? So I wonder what would happen if you're doing jumping jacks, you know, that kind of thing. But it's detecting it. And then basically it has some register somewhere where it's storing the value. And every time you take a step, it does a plus equals 1, right? For every step you take. Now it says, in addition to tracking steps, your fitness tracking app tracks distance traveled. So create a variable called distance of type double and set it equal to 50. So let's do that down here. So here's a variable called distance double, and we're setting that to be 50. And supposedly this will equal 50 feet. You decide, however, to display the distance in meters. 1 meter is approximately equal to 3 feet, right? Use a compound assignment operator to convert distance to meters and then print the result. Okay, so now this is a little more challenging to think about, right? So 1 meter is approximately equal to 3 feet. It says use a compound assignment operator to convert distance to meters. So I'm going to set up a variable called meters, right? Not to declare a data type, but I could, right? So what do I do here as a compound operator to declare this? This is kind of a weird one.
So would it be 50 divided by 3?
Well, that's how we get to the answer.
Oh, okay.
Okay. And you know, I'll be real frank, Jonathan, I'm not really sure if maybe what they mean is we keep using distance, you know, and this might be it, right? So what would we do then to get divided by 3? Divide equals
So
3?
divide equals, yeah.
And I think that would be correct. And notice that it gives us 16.6 repeating on that one. Right? And it says print the results, so we would print. And to make sure it's meters, right? Or whatever. I mean, you can use double quotes here and just go backslash distance meters, right at that point. So it would be 16 point whatever meters. You know, the whole point of this one is to use the compound operators, right? So I wouldn't throw another variable into the mix just to make that happen. All right, we're going to move on to the next one, folks. All right, we also have this thing to worry about called the order of operations. Remember, there's this acronym that we call PEMDAS, PEMDAS. And I'm just going to type it out on the screen. And actually, I'm making a mistake here. I should not do that there. See how I deleted all the original code, but PMDAS, right, which stands for parentheses first, exponents, multiply, divide, add, subtract in that order. But generally speaking, like multiply, divide are on the same level, add, subtract are on the same level, but you have to choose one or the other. Multiply goes first, add goes first. Whatever's inside parentheses goes before stuff that's not. Whatever has an exponent goes before all the others. Right? And that's one that you guys should already know, but that does apply here in basically every programming language. And knowing how to leverage that, it makes a difference, you know, and this is kind of what's interesting, because if we look at that first little direction there, it says print out what you think 10 plus 2 times 5 evaluates to. Now, if I read it and do the math, I go 10 plus 2 is 12 times 5. Well, it's 60. But the order of operations will dictate that 2 times 5 goes first. So it's actually 10 plus 10 or 20. So in other words, they want us to try that. They want us to actually put that in the print statement, and you can do that. So I can go 10 plus 2 times 5. And if you look at the sidebar in a moment, you'll see that it goes to 20. It knows the order of operations, right? If I wanted to force it to go a different way, right, and to make it go the way that I first read it, I would need to add another set of parentheses to go around the 10 plus 2 to make sure that happens first, and then look at the output. Now it is 60 because 10 plus 2 is 12 times 5 is 60. But the parentheses force that to go first. So kind of the real big takeaway on this, real frankly, is if you can write an equation correctly without putting in extra parentheses, you do that when you understand the order of operations. If you're not sure, or it confuses you, or you want to make extra sure the code does it correctly, you put the parentheses in. It's like no harm done, right? So add them typically is kind of a suggestion. Now the next one, 4 times 9 minus 6 divided by 2. This one's a little trickier because now we got two higher level operations. So if we read it left to right, 4 times 9 is 36, minus 6 is 30, divided by 2 is 15. Okay, great. But the reality is, if I put that in, 4 times 9 minus 6 divided by 2 gives me 33. Why? 4 times 9 happens first, that's 36. Then 6 divided by 2 happens, which is 3. 36 minus 3, 33, right? And so there it is. Then they want us once again to rewrite this so that it says add in the parentheses so that subtraction is prioritized over multiplication and division. So if I put parentheses around the 9 minus 6, right? So 9 minus 6 is 3. 4 times 3 is 12. Divide by 2 is 6. Right. And I think you guys already get this concept because I think we covered it pretty well in the first course, but sometimes we forget, frankly. But the whole point of this is order of operations, parentheses help us to tweak that and control it. Whenever in doubt, use parentheses to make sure. All right, moving on. So this is another one of the app exercises here. So let's try to nail this one down and complete it. It says, if you completed the fitness calculations exercise, you calculated an average heart rate to display to the user. However, using proper order of operations, you can do this in fewer steps. Create 3 separate heart rate constants, all of type double, and then create a constant equal to the average heart rate. If you use the correct order of operations, you can do the heart calculation in one line. Okay, so that's what we're going to do. So here we are. We're going to create 3 separate heart rate constants, and I'm going to really abbreviate in this. I'm going to go HR1. They should all be doubles. And I'm going to set the first one to values that were similar to what I had before. So I'm going to set one to 64. And then we're going to do let HR2 colon double equal 79. Let HR3 double equal 98. Okay. Then they want us to create a constant equal to the average heart rate. So we're going to say let, let's just call it AVGHR. That's my abbreviation. Should this be a double? Sure, let's make it a double. I'm going to tell you it doesn't really matter since we're doing the math with doubles. It'll still be a double, but I think the habit is better to do it. And how would we do this? Well, I would take HR1, and you notice the parentheses here, right? Plus HR2 plus HR3. And all of that divide by 3. A real common mistake that young programmers make when they're doing averages is they forget the parentheses. The number you're dividing by happens first, and then it's off, right? But this would be the correct way. Yeah, you can do it all in one fell swoop. I get really impressed when I see young programmers who see the math and understand the math. And sometimes you can take a series of complicated equations and boil them down to one step if you're a clever mathematician, and then it's just all in the setup and the syntax. All right. Next task is one feature you might want to give users is to display their current body temperature, create a constant temp in Fahrenheit equal to 98.6. Let's do that. So temp in Fahrenheit. And that's equal to 98.6. What's our data type? Double, right? It's a given. May want to also show the temperature in Celsius, so you can convert Fahrenheit to Celsius by taking temp in Fahrenheit, subtracting 32, then multiplying the result by 5.0 divided by 9.0. Kind of interesting, right? All right. So, all right, so let's do that. Let's create a constant. We're going to call it let temp in Celsius equal. Okay, so it tells us what to do. Temp in Fahrenheit minus 32, then multiply the result. So do you see this, the syntax here? So what they're really saying is when they say then multiply the result of that. So what they're really saying is put parentheses around Fahrenheit minus 32. And then multiply that by 5.0 divided by 9.0. Does it make a difference if I'm using decimal points here? Well, it does, right? Because like if I experimented and I did 5 divided by 9, that's integer division, right? It's not as precise. And this is the actual formula that we use, by the way, for determining this. So if I have a body temperature of 98.6, in Celsius, it's 37, right? How could I test this? Well, I know that 32 degrees Fahrenheit is the same as, aha. Okay, it says binary operator cannot be applied to operands of type int and type double. You see what happened here? Like I made this now an integer. You see the difference there? Because I changed this and now it doesn't want to do the math. So I would contend, right? And this is, I think, where they're trying to lead us. It is always a smart idea that if you're not sure how your math is going to turn out, make sure that you select the right types to go with it. Because I would rather have the precision than not. And you can get rid of the precision in your output. But notice here, when I change it to 32, then I do get 0 degrees. So 32 degrees, which is freezing in Fahrenheit, is 0 degrees Celsius. And then the boiling point in Fahrenheit is 212, which equals 100 in Celsius. So if I'm at 98.6, am I really at 37? Or am I at, well, did you notice that it cast itself? I don't know if you saw that for a second. It was 36.666, right? Why? This is floating point, floating point, floating point. Having one non-floating point number changes it to an integer. It's kind of interesting, isn't it? Right? So if I change this to 32.0, will I get more precision here? It's kind of an interesting, this is an interesting experiment. All right. So regardless, we're really, really close to accurate, but what you cast to value-wise does make a difference. And so this is something you always keep an eye on as a programmer. You cannot just count on the fact that your equation is working correctly you need to know what working correctly looks like. And unfortunately, for a lot of math equations, that means running the math equations. What I find is really helpful, and I say this to all my programming students, is knowing how to use a spreadsheet program like Excel, or if you're on a Mac, Numbers, or if you're, Google Spreadsheets or whatever, knowing how to do formulas to validate what you're getting here. Also, just having a calculator handy helps to know what the results should be in advance is really kind of the safety net. All right, we're gonna press forward here. We only have a couple more playground pages to do, and then we're done. And the timing is going to work out perfectly here. So here we have create an integer constant x with a value of 10. We're going to say let x colon int equal 10. All right. Add a double constant y with a value of 3.2. Let y colon double equal 3.2. Create a constant multiplied as integers. All right. Let multiply as integers equal to x times y. Now we've already experimented with this, and this is actually kind of shocking, right? Like the first time I saw this in Swift, I was a little shocked by this, because if I did the same thing Python or JavaScript, well, first of all, those languages just don't care, right? But in Java, if I was multiplying an int and a double, it would pick up whichever the higher level one was and convert the answer to the higher level. That's how Java operates, right? And you can leverage that, right? It's called casting, right? Here, I cannot expressly multiply x and y and treat them like they're integers and have it work, and then store it back in this variable that we don't even know what type it is, right? And it says print the result. Okay, if it doesn't work, it says fix it by converting your double to an int. All right, so I'm going to convert this to an int. Now does it work? Well, now we have a different problem, right? Because that's not a double, right? And then it doesn't want us to print the result, so we should just multiply as integers, right, just to see the result. But it can't do that either. So we either have to change that number, right, or switch it back to double, right? And maybe, just maybe, this is another way to do it. Switch this to a double, even though it's an integer, and then it operates. But this is a really important little feature, because I can't take two values, store them somewhere where the type is unclear, and have it work. Okay, let's Control Z this. Let's change that back to an integer. What if I change this to a double? Still has the same problem. What if I change this to an int? Still has the same problem. So the bottom line becomes, you cannot mix data types in equations. So like when you're working on stuff and you start to realize that, hey, I need to multiply a double and an integer, I better think about this, right? And so what Swift makes you do is you need to think about it in advance and fix it. All right. Next, it says create a constant called multiplied as doubles equals to x times y, but this time convert the int to a double in the expression. Now, we already kind of did that, right? You guys agree?
Yeah.
Yeah.
Mm-hmm.
And so we can see how it works. So if we change the the expression here, it does, and I'll just say, see above, because we already did it. Are the values of multiplied as integers and multiplied as doubles different? Yeah, well, they, of course they are, right? The only difference really is that there's the floating point number at the end. So I'm not really demonstrating that. And really what they wanted us to do is do one as int times int and another one as double times double. But what you can't do is int times double or double times int, right? It's got to be the same. And so for this one too, I'll say see above. We're on that last slide, so let's be brave here and try to get this done in the couple minutes we have left. It says if you completed the fitness calculation exercise, you calculated the percentage of daily step goal the user has achieved. However, you did this by having steps be of type double, but you can't really track a partial step, so steps probably should be an int. Go ahead and declare steps as type int and give it a value between 500 and 6,000. So let steps int equal, I don't know, let's go with 2,345. That's my number. Then declare goal as type int. So we're going to say let goal type int equal 10,000. Now create a constant percent goal. This is of type double. That equals the percent the goal has reached so far. So you need to convert your constants of type int to be of type double in your calculation. All right, so normally what we would do is we would just say, what would be the math on this? Steps divide by goal, right? That's the grand calculation. But we need to do a conversion. Now, this is where I'm going to cheat and look at the teacher's guide here for a moment, because real frankly, I'm not sure what technique they want me to use. So I'm going to look, so that's one of the reasons why we have these. So I'm going to look at that playground. Go to that last slide. You can see that I haven't even been there yet, but we're going to go here and see, this is the technique they want us to use. So this makes it clear to me that they're doing an in-place conversion. And this is kind of the technique that they're really leading us to. And so I wasn't sure if they were putting it around the equation, but they're putting around each individual value. So in other words, we'll say the keyword double, because that's what we want to switch it to, and wrap it around our variable. Same thing here, wrapping it around our variable. So now the math can actually work. But if we run this, it doesn't look like a percentage. So then we would just simply multiply by 100 to give us what looks like a percentage. Then, of course, if you want to print it, you can do a little string interpolation and say, put the percent sign after it this way, right? And then you actually get the output you're looking for. So 23.45%. Of course, you should be more verbose. So you should say like 2345 is 23.45% of 10,000, a percent of your goal. All right, folks, I'm gonna stop the recording here.